This is the third biostatistics lecture. This is going to be on odds ratio and relative risk. So first of all, try to pause the video. Just try to read through this extract of an article and stay speechless and ask yourself, I really don't understand this. And after that, we're gonna explain this so you understand it, and trying to figure this out, I actually understood this. So let me know in the comment section if you could handle it. Okay, let's go. So these are my notes. We'll go piece by piece, break it down into those little tiny pieces. So first of all, we have to do these 2 by 2 tables. And what's the first thing we have to do whenever we're trying to see odds ratio or relative risk? First, we have to know what's the outcome, what's the disease. Is it, okay, lung cancer, yes, lung cancer, no. Then we have to know what's the outcome we're searching for. You can't go searching for 5 different outcomes at a time. You have to go one by one. That's the way all this science has been developed over the decades, or years, millennia, whatever you want to call it. So exposure, yes to smoking or no to smoking. Then you have your 2 by 2 table, and you can put on the nice little letters on it, A, B, C, and D. Try to put the outcome on the x-axis and exposure on the y-axis in order for you to have a mental framework for to start off. So, okay, so now let's get into the action. Risk. Whenever you're trying to see risk, you're talking about time. The only way that you know that you're at risk for something is you have to give it time. You won't be at risk to be devoured by any strange creature if you don't have time to for this creature to approximate you, right? That's a strange analogy. Hope you pause time before this creature approximates. So the thing is that you need time for risk to develop and for you to assess risk. So we're talking of in order to measure risk, we're talking about prospective study designs. What are good examples of prospective study designs? Yeah, randomized control trials are great examples. And you know that you have to sit down there and wait a long time. So that's why during this pandemic, probably you don't have much data from or risk assessments. What you have is other assessments that we'll see in the next slide. So risk, for an example, is calculating the 10-year risk for lung cancer in exposed or in smokers versus non-smokers. There you have a nice explanation of a prospective study design where you can calculate the risk. And what is the nice little 2-lettered acronym you'll use? Relative risk. So relative risk tries to answer the next question. Within an X and Y amount of time, what's the risk for the exposed group to develop the disease compared to the unexposed group? Okay, that's what relative risk answers. How will you calculate this? Okay, here I have a mnemonic for you. I just came up with it. Not sure if it was in the back of my mind and someone already had thought about it. Just let me know. Let me know if you liked it or have a better one. Read the alphabet from left to right. So read the alphabet to the right, starting from the top. So if you're reading this text right here, you'll read to the right and you'll read from top to bottom. What are the probabilities of you doing that? Almost 100%. And you're trying to figure out the probability right here, because relative risk is a probabilities, yeah, right? So you're going to read this from left to right, to the right. So how do you calculate this? Relative risk is equal to A, which A is you have the disease and you were exposed, but you divide that, or you divide that by the grander group, which is all those that were exposed, what represents all the persons exposed to the risk factor, this line right here. So it would be A plus B. That's why you have A plus B in the denominator right here. What will you do with what's down here? You'll do the same thing. So now you want to compare the risk in to the group that was not exposed. So here you have the group that wasn't exposed to smoking. So it would be C over the whole group of non-exposed people, non-smokers, which would be C plus D. There you have the way of how you figure out the relative risk in a 2x2 table. Now, how do you measure this? You measure this from 0 to infinity. You won't have a relative risk of a negative number. It will always be from 0 to infinity. Relative risk of 1 means that the incidence in the exposed and unexposed is equal. More than 1 means that the exposed group incidence is more, and less than 1 means that the exposed group incidence was less. So less than 1, actually you might be talking about a protective factor, and more than 1 you might be talking about a actual risk factor. And odds ratio isn't the same to odds ratio. That's why we're making this video lecture right here. The only time you can say that odds ratio is very similar to odds ratio is when you have a very, very rare disease. Why does this happen? Because the prevalence of the disease is so slim that the denominators in these mathematical formulas are so small that everything balances out, and you might say that odds ratio would be very similar to relative risk, and that's called the rare disease assumption. So now let's talk about odds ratio. So we already talked about the RR and prospective trials. If you have these other studies which are case control, or whenever someone wants to publish something, the fastest way to get it is a retrospective study design. You usually have a statistician that might help you out making some type of regression. You're usually talking about odds ratio. Okay, so retrospective means that you're in the future and you're looking backwards. You already have all the cases. You already have all the controls. So you will compare an equal amount of people with the case or with the disease to the same amount of people without the disease. What will you see? You will try to figure out how many more times those with the disease were exposed to smoking versus those that did not have the disease. So if you know the disease, if the lung cancer is known, I cannot calculate the risk of developing lung cancer, but I can calculate the odds of exposure in those with the disease and those without the disease. So the odds ratio tries to answer the next question. What are the odds that X or lung cancer were more exposed to a particular factor compared to the control group? And basically, here we have a short fragment of the article I showed you in the first slide. Now we're making sense of this, and we're just gonna read this extract. For example, we learned the odds that a heart disease patient will be a smoker, not the odds that a smoker will get heart disease. The odds of being a smoker can be divided by those of not being a smoker, resulting in the odds ratio for the risk factor. Okay, so this is how you will calculate odds ratio. You have to make the same 2x2 table, but this time you'll work it differently. This time you'll not go to the right. This time you'll go downwards. So if you like the long road, you will go down long. If you don't want to make this used for all these two fractions or these couple fractions, and you want to simplify, you will go oblique. What does this mean? If you make sense of these two are the same. The mathematical relationship between these two is that you make this A goes with the higher up goes with the lower one. So A goes with D, C goes with B, ending up like this, AD over BC. But let's try to understand this. So let's see, a person with lung cancer, they're asking us the odds ratio of the exposed versus non-exposed of for smoking. So you have lung cancer, okay, and here's smoking, okay. So smokers with lung cancer over those with lung cancer that didn't smoke. There you have A over C. Then that you have to compare it to those who did not, right here, those who did not develop lung cancer, and over D, who did not smoke. Okay, so you're figuring out something different here. In odds ratio, you're going downwards instead of this side. This is difficult to grasp right now. As I'm trying to explain it, I'm asking myself questions, as you can see, but the thing is that you have to have clarity in order to know what way to go. At least try to answer the questions. Then after you answer the questions, you can go sit down with a glass of wine and think it through 3 hours if you wish. But with the next slide, we'll explain this a little better. But this is the way you go with odds ratio. So oblique. So this is how we'll understand it better. Odds ratio equals, in the higher portion, you have the odds that a case was exposed. Okay, what are the odds that this case was exposed? Okay, so case, we have here A, that this person was exposed would be A over the non-exposed, because you're seeing the odds. So A over C. And that you have to divide it over the odds that the control was exposed. So here you have control exposed right here, B. Okay, so B over D. And that will give you, in the end, this formula, AD over BC. Okay, so for relative risks, we were actually calculating probability with that lung fraction going to the right. With odds, we aren't exactly calculating probability. It's a way of manifesting probability, but it isn't exactly probability, because as you saw, odds will eventually be probability over 1 minus probability. So let's use this example. 60% probability that I will win this race equals an odds of 1.5. Doesn't make sense, right? 60%, you could convert it into 0.6. And odds of 1.5 sounds much more, right? Much more than 0.6. So what happened? So if you have 60%, let's go back one slide. 60% of winning the case. 60% of how much? How much would go here? 100%, right? So 60 plus, and this number should be something that adds up to 100%. This would be a 40. So 60% would be the probability. But if you're trying to figure out the odds, you would do this number over this one. 60 right here, 40 right here. 60 divided by 40 would give you 1.5. So odds ratio usually magnifies the effect in studies, and as clinical practitioners, we have to know that odds ratios will usually give us magnified results, and things that look exaggerated, we have to put this in the context of knowing that odds ratio isn't the same as relative risk, because they are odds. Okay, and to wrap off, we have right here what each of these two try to search. So look at the colors. Relative risk. So we have probability that an exposed gets the disease right here, over the probability that an unexposed gets the disease. So relative risk focuses on the disease or the outcome, while the odds ratio focuses on exposure because you already have the outcome. That's why odds ratio, you have odds that a case was exposed over the odds that a control was exposed. So that being said, this video couldn't be less than 5 minutes for sure. I'm just gonna wrap it up right here. Let me know what you thought. And I'll also add all the links I use. I just used 3 resources. One is USMLE Biostatistics. 2 is this great video from Christine Rabenak. And 3 is the article I showed you at the top. I've spent a couple of hours doing this, so hope it works out for you. And let me know if you liked it, didn't, whatever. See you in the next one.